right now, at this exact second, 150 million kilometers away. The Sunday is detonating. Nuclear fusion, hydrogen atoms slamming together at 15 million degrees Celsius, releasing energy so violent that a single second of it could power all of human civilization for 500,000 years. And a tiny fraction of that explosion is heading directly toward your face. It left the Sunday 8 minutes and 20 seconds ago. It has been crossing empty, frozen space at 300,000 kilometers per s-econd. And the moment it hits Earth, it doesn't just warm your skin. It runs the entire climate. It drives every weather system on the planet. It generates the northern lights. It can knock out power grids across entire continents. And it does all of this through 5 completely different mechanisms, most of which are happening right now above your head, and most of which almost nobody knows about. This is what actually happens when the Sunday hits Earth. Let's start with the moment that light arrives. The photon that is about to hit Earth was born inside the Sunday's core. But here is something most people don't know. It didn't travel from the core to the surface in 8 minutes. It took that photon 100,000 years just to fight its way from the Sunday's core to its surface, bouncing off particles being absorbed and re-emitted, trapped in an endless collision course through dense plasma, 100,000 years inside the Sunday, then 8 minutes and 20 seconds across 150 million kilometers of nothing. It arrives carrying a spectrum of energy, visible light, the part your eyes detect, ultraviolet radiation, invisible high energy, dangerous to cells, infrared radiation, invisible felt as heat on your skin, X-rays and gamma rays, extreme energy, mostly filtered before they reach you. All of these arrive simultaneously, and the moment they hit the top of Earth's atmosphere, the planet's defense systems kick in speed of sunlight, 299,792 kilometers per s-distance to Earth, 149.6 million kilometers travel time. 8 minutes 20 sec. Earth is about to do something extraordinary with all of it. The moment solar radiation hits the top of the atmosphere, Earth starts making decisions. About 30% is immediately reflected back into space. Clouds act like giant mirrors, bouncing sunlight before it can do anything. White ice caps reflected. Light-colored surfaces send it back. The remaining 70% enters the system. It hits land, oceans, mountains, forests. And all of that absorbed energy converts light into heat. The oceans absorb an enormous share of this energy, slowly releasing it back into the atmosphere over weeks and months, acting as a planetary heat battery that keeps temperature changes gradual instead of catastrophic. Without this absorption, the side of Earth facing the Sunday would be scorched to several hundred degrees. The night side would drop to -100 every night. Every day, a world of extremes. Instead, that 70% of absorbed solar energy maintains Earth's average surface temperature at 15 degrees Celsius, 59 degrees Fahrenheit. The precise narrow range where liquid water exists, where life is possible, where you can walk outside without a spacesuit. The atmosphere isn't just air. It is the most sophisticated climate regulator in the solar system. And it is also performing a second function simultaneously, one that is invisible but keeps you alive every single day. At roughly 15 to 35 kilometers above your head, something extraordinary is happening right now. The ozone layer, a thin band of O molecules in the stratosphere, is absorbing ultraviolet radiation before it reaches you, not filtering it, not reflecting it, absorbing it. UV radiation carries enough energy to break the chemical bonds in DNA. Without the ozone layer, every minute of sun exposure would be like standing under a UV sterilization lamp designed to kill microorganisms. Here is how it works. A UV photon hits an ozone molecule. The ozone molecule absorbs the energy and splits, the fragments recombine. The photon's energy becomes heat instead of reaching your skin. The ozone layer converts dangerous UV into harmless warmth about 97 to 99% of the time. The 1 to 3% that gets through is enough for vitamin D synthesis. enough for tanning, enough to cause sunburn if you are out too long. The ozone layer is calibrated almost perfectly for life. But here is what makes this mechanism remarkable. It is self-repairing. Under normal conditions, ozone molecules that split recombine constantly. The layer regenerates itself continuously as long as the chemistry isn't disrupted. Nature built a UV shield that maintains itself 25 kilometers above your head. Right now, the sunlight that reached Earth's surface has now been absorbed. The land and oceans warmed up, and now they try to release that energy back into space as infrared radiation, heat radiating upward into the night sky. Without intervention, that heat would escape. Earth would cool rapidly after sunset. By morning, the surface would be around minus 18 degrees Celsius, minus 0.4 degrees Fahrenheit, frozen every night everywhere. But something intercepts that escaping heat, greenhouse gases, water vapor, carbon dioxide, methane, nitrous oxide. Molecules in the atmosphere whose structure allows them to do something remarkable. They absorb infrared radiation, heat trying to escape, and re-radiate it in all directions, including back down toward the surface. Think of it like a blanket. The Sunday provides the warmth. The greenhouse gases trap it close to the surface. The planet stays warm enough for liquid water, for life, around the clock. This is called the greenhouse effect, and without it, Earth would be a frozen rock. The naturally occurring greenhouse effect keeps Earth approximately 33 degrees Celsius warmer than it would otherwise be. The effect that is discussed as a problem today isn't that the greenhouse effect exists. It is that the concentration of these gases is increasing, making the blanket thicker, trapping more heat than the system was calibrated for. The mechanism is ancient. The balance is recent. And the Sunday's energy is what the whole system is managing. But sunlight isn't the only thing the Sunday sends. Along with photons, Earth is being hit right now by a constant stream of charged particles. Electrons, protons, alpha particles, ejected from the Sunday's outer atmosphere at 400 to 800 kilometers per second. This is called the solar wind, and it never stops, day and night. Every day of the year, it hammers the side of Earth facing the Sunday. Without protection, the solar wind would strip away the atmosphere. We know this because it happened on Mars. Mars had no strong magnetic field. The solar wind eroded its atmosphere over billions of years. Today Mars has an atmospheric pressure less than 1% of Earth's. Too thin to support liquid water, too thin to support life as we know it. Earth survived because of something deep inside it. The planet's iron-nickel core, churning liquid metal generating electrical currents, creates a magnetic field that extends 65,000 kilometers into space. The magnetosphere, the solar wind, hits this field at full speed, and the field deflects it, curves around Earth like water around a stone, protecting the atmosphere, protecting the surface, protecting every living thing that has ever existed on this planet. But some particles aren't deflected. At the poles, the magnetic field lines converge, funnel-shaped. Charged solar wind particles spiral down these funnels and collide with oxygen and nitrogen molecules in the upper atmosphere. Those collisions release energy as light green, pink, purple, white light dancing across the polar sky. The aurora borealis, the aurora australis, the northern and southern lights aren't just beautiful. They are the visible proof that Earth's magnetic field is working. The glow of your planet's defense system operating at the poles. So the Sunday sends light. Earth absorbs and manages it. The Sunday sends solar wind. The magnetosphere deflects it. Everything is in balance. Until the Sunday does something violent. Several times per year, more during solar maximum, the Sunday produces an explosion so powerful it makes every nuclear weapon ever built look like a firecracker. A coronal mass ejection. A CME, billions of tons of magnetized plasma ejected from the Sunday at up to 3,000 kilometers per second. A wave of charged particles and magnetic field the size of multiple Earths traveling through space at a fraction of the speed of light. When a major CME hits Earth's magnetosphere, it doesn't just push, it compresses and distorts the entire magnetic field. The field that normally extends 65,000 kilometers into space gets shoved back to 6,000 or 7,000 kilometers on the sun-facing side. The stress propagates through the field. Magnetic field lines snap and reconnect, releasing enormous bursts of energy. This is a geomagnetic storm, and it cascades down into technology in ways most people never anticipate. GPS systems drift. Satellites drift from their calibrated orbits because the upper atmosphere expands, increasing drag on low orbits spacecraft. Radio communications fail. The ionosphere, normally a reliable reflector of radio waves, gets disrupted. Blackouts across entire frequencies. Power grids overload. The fluctuating magnetic field induces electrical currents in long ground-based conductors, pipelines, rail lines, power cables. Transformers that handle hundreds of thousands of volts can saturate, overheat, and fail. In 1989, a geomagnetic storm knocked out the entire power grid of Quebec's 6 million people. No power for 9 hours in March in Canada. In 1859, the Carrington Event, the largest recorded solar storm, hit telegraph wires so hard that operators got electric shocks. Some telegraphs continued operating, even after being disconnected from their batteries, powered entirely by the induced current from the storm. Scientists estimate that if the Carrington Event happened today, hitting a world now dependent on satellites, GPS, internet infrastructure, and interconnected power grids, the economic damage could reach several $1 trillion. Months of outages, infrastructure damage that would take years to repair. Earth's magnetic field keeps us safe from the solar wind every day, but against the largest CMEs, we're more vulnerable now than we've ever been. The Sunday hasn't changed, we have. So let's go back to where we started, that photon that left the Sunday 8 minutes and 20 seconds ago. By the time it hits Earth, it doesn't just arrive. It triggers a cascade, 30% reflected back to space. Earth's albedo keeping temperatures stable, UV absorbed by ozone, protecting DNA in every organism on the surface. Infrared trapped by greenhouse gases, keeping liquid water possible. Solar wind deflected by the magnetosphere, preserving the atmosphere itself. CMEs absorbed or redirected, with consequences when they're strong enough. Every one of these systems is operating right now above you, around you, because of you. You exist because all 5 work together for 4.5 billion years without failing catastrophically. The ozone layer repaired itself, the magnetic field held, the greenhouse effect stayed within its range. The atmosphere remained. We often think of the Sunday as just the thing that makes days warm and summers long. But what actually hits Earth every day is a stream of energy and particles that this planet has spent billions of years building systems to manage. And the margin between life as we know it in frozen rock or stripped atmosphere is thinner than most people ever stop to consider. The next time you feel sunlight on your face, that is not just warmth. That is the end result of the most complex energy management system in the known solar system, working perfectly for you. Right now, if you want to go deeper on what happens when solar storms get truly extreme, the Carrington Event, the 1989 Quebec blackout, and what a direct hit from a Carrington-level storm would do to modern civilization, that video is next. Subscribe so it finds you. I'll see you in the next one.